linear functions. Okay, so definition. I don't know if you can read the purple very well. I'll explain the definition, and then I'll explain the picture too. Another thing you might want to write is input equals x and output equals y. Input equals x, output equals y. Who said that? I never tell them they can throw them away. That would stink. It was Trevor. He didn't take any notes. Well, that's you snooze, you lose. Maybe we'll see. We'll see how this goes. All right. So function. A relationship where the input depends on the output. Put something in, get something out. So you're like, I still don't get it. This is my function machine. Okay? This is my function machine. I'm gonna put something into it. Something's gonna happen in here, and then something's gonna come out. Okay, now think about it this way. A real life function machine is a pop machine. What am I gonna put into the pop machine? What am I gonna get out? Okay, that's a function. That's a real life function machine. You have many real life function machines in your life. Okay, you are coming back here next year. Not a, oh my gosh, a pop. Jeez. Anyway, what are some other real life function machines in your life? Okay, I'm gonna come back to that. Okay, put a tree in a machine and comes out wood shavings. Oh. Okay. Okay, here's another function machine that you have in your everyday life. A washing machine. What do you put in? Dirty clothes, you get out clean clothes. Hey. Another function machine, a toaster. Put in bread, you get out toast. Hunter. Okay, that's a function. It might not be a legit machine, but it's seriously a function. An oven. Oh my gosh, an oven. Perfect. Yep. You are a function machine. Think your bodily functions, but I'm going to make it a little cleaner than what you people were talking about before. Think about in your body, you put in calories. What is the result of putting in calories to your body? Energy. Energy is the result of that. Okay. Okay, another function machine. How much you study for a test? Because what do you get out of it? A good grade. What you study and how much you study really your outcome of your test depends on what you did. If you study 0, what's your outcome of your test going to be? Not good. If you study really hard, your outcome of your test is going to be really good. That's a function. Okay? So I have some other vocab here. I'm going to have you write these, and I'll explain them, and then I'm going to put everything together for you, why we're talking about functions, why we're talking about these things. Okay? So today is basically just an introduction day to different parts of things. Okay? So function, yes? So write these down, and I'll explain what they are. Probably be a good idea because we're going to use it a lot tomorrow. Can I talk about this first and then answer your question? Is my talking going to answer your question? Okay, hit me. I'll show you. I could have solved this. I could have answered this when I talked about this, but Carver thought it was above me, so. All right, a relation. A set of order pairs. What is an order pair? Okay, X and Y. Remember we deal with X and Y. If I have the order pair 2, 3, how you know how to graph that? It's some of it's graphing. This chapter, some of it's graphing. Okay. So a relation or order pairs like 2, 3, 4, 1, 9, 6. Now we aren't going to deal with a lot of order pairs today, but we will start dealing with more order pairs along the line here. Domain. So let's say you're given a whole bunch of ordered pairs. Okay, like a list of them. The domains are all the x's in there. Because remember your order pairs are always xy. Oops. They're always xy. Now if I'm given a whole bunch of those, all my x's would be considered my domain. Okay? Now the range is all the y's. So then all the y's would be considered the range. Now I'll show you how this works in a second. Independent variable. It's what you're going to put in. Okay, so let's think of that pop machine. I'm going to put in money. Washing machine, I'm going to put in those dirty clothes. Toaster, I'm going to put in bread. Now, what I put in, or what I get in the end, is that going to depend when I put in? Yeah, definitely. So my answer is going to be my dependent variable, because what I get in the end, think of your test. We just talked about this. What you get on that test, does that depend on how much you studied? Okay, so that's why the output is dependent, because that output depends on what you did in the first place. Does that make sense to everybody? So here's an example. I have an equation. We dealt with equations the last how many chapters? My independent variable is this. My dependent is my answer, because does my answer depend on what I put in there? Yes, it does, right? If I put a 1 in there, that determines what this is. If I put a 3 in there, that determines what this is. This is going to depend on whatever number I put in x, and that's why it's okay to have a 2 in front, because I'm just solving the equation. Okay, I'm just solving that. So whatever I put in for x, my answer is going to depend on that variable or that number I put in. Okay. How is this working today? Okay, so functions. We're going to go back to function. What is it again? You put something in, you get something out. That's just a simple, basic rule of functions. Basic definition. There are 2 rules of functions, though, that you have to know. Otherwise, you're never going to get through your homework today. And I know it looks like a lot of writing. This is definition, or this is rule number 1. This is rule number 2. If I were you, I would write this. This, and I would write this. You don't have to. It's easier just to do this. And I'm going to add some things to these. So don't leave a little space underneath your tables. Leave a little space underneath your tables. And if it's a function or not. That's right, a function, exclamation mark, exclamation mark. So rule number 1 is this. Rule number 2 is this. underneath this first one, I want you to write y's can be the same. Notice how my y's are the same here. For not a function, x's can't be the same. Some of you are like, this is crazy, I don't get it. Okay, so let's talk about it. Think of your function machine. I'm going to go to the store. That's going to be like my function machine. Okay, so let's say I go to the store, and I'm going to buy 3 bags of candy for $10. When I went last week, that's what I know they cost. 3 bags of candy for 10 bucks. Okay? Let's say I go to the store, and all of a sudden there's a coupon there. And guess what it says? 5 bags of candy for $10. Does that work? Am I still buying? Let me rephrase that. I'm still paying the same amount, but getting different bags of candy, right? Okay, so that's why this can be considered a function. That's why your y's, so I'm going to come back to this and explain it later, my y's can be the same and it can be a function. Okay, so I have different bags of candy and I paid the same amount. Now let's go back to the store and we'll talk about, this is number 2 now. I'm going back to the store and I see that 9 pizzas are on sale for 30 bucks. That's like a really good deal. Okay, 9 frozen pizzas for $30. I'm buying 9 of them. So I put 9 in my cart and I go up to the front and they check me out and I say, okay, yep, $30. And then I get back to my cart and say, you know what, I'm going to have a party next weekend, so I'm going to go stock up again. I'm just going to run back into the store and grab 9 more. But guess what, when I get back in, she charges me what? 40 bucks. No coupon, nothing was changed. So guess what? That's not considered a function because you just can't randomly switch something up like that. Okay? So that's why this is not a function. And your x's can't be the same. Now let me show you how this is going to work. Okay? So you're like, I still don't get it. I'm going to give you a relation like this. Remember we said a relation is a set of pairs. Okay? And I'm going to have you tell me if it's a function or not. The easiest way to do this is to make a t-chart. And make this your x column and make this your y column. Okay? Then I'm going to go through all of my points and I'm going to put them. So like -3, 1, there's 1. -2, 4. -1, 7. 0, 10. 1, 13. Okay? And now I can easily look down them and say, okay, to make this a function, I know I can have no x's that are alike. Because that's what it says in there, right? I can have no x's that are alike. That's what you just took as a note from me, I believe. Y's can be the same, x's can't be. So I really am going to look at what column? The x's. Because I don't care about my y's. I'm looking at my x's. So if I look down my x column, do I have any of the same number? So this would be considered a function. It does work. And then, remember we went back to our vocab, we had domain and range? Remember that? Domain and range? Yeah, now we're going to do that again. We're going to do that again. So domain is what type? Okay. And range is the? Right. That's part of it. That's part. This is a part. What if I would put this in there? Not a function. Why? Because 2 -3's in the x column. They're going to ask you to tell if this is a function and explain why or why not. Okay? On your homework today. Oh, I meant range. But that is my y's. That's what I meant. Sorry. Thank you. All right, so I can have the same y's, but I cannot have the same x's. So let's go to the next one. Okay, this is already in a table for me. So I technically don't even need to put it in a table because it's already in one, except for it's just turned the other way. So what do I have to look at for my x's this time? I have to look at across, right? Any of my x's the same? Okay, so this would be a function. And my domain would be what? Okay. And my range is down here. And let's say I would add this in. Would this be a function? Y's can be the same, so this would be considered a function. Y's can be the same. That's like me using my coupon. Okay, Y's can be the same. X's, my X's are fine. Nothing is the same. Okay, any questions so far? So this is what's going to happen. In your homework, they're going to show you this, and they're going to ask you if this is a relation or if this is a function. They're going to show you something like this and ask you if this is a function. And the last thing they're going to show you is something like this. They're going to actually show you a graph and ask you if this is a function or not. Super easy way to tell. Because how many of us want to go through each point and label their ordered pair? No? Nobody? Okay, well, luckily there's an easier way. Okay? Yes. Because you can't have the same one. Well, you can't have the same X. So here's how this vertical line test works. You're going to take your pencil, your finger, whatever, and you're going to go to the first dot, and you're going to say, is there any other dots on this line? Next one, any other dots? This one? This one? This one? Okay. Now, some of you are like, well, I don't get it. Well, watch what the ordered pair is. This is 1, 1, and this is 1, 6. What do they have the same? The X's. So that's why you can't have two dots on the same line because they have the same X's. Yes? So this would not be considered a function because of that. Because you have two X's that are the same thing. Does that make sense to everybody? Yep, they have it on there for you. If I would not have that, let's say it's gone, this would be a function then because there's nothing on the same line. Okay, you can't go this way because then you'd be checking the Y's. All right, so you have to go vertical up and down because then you're actually checking the X's. So there's a reason why you have to go up and down because that's how you check the X's. Okay, so you're going to be given this and asked if it's a function. You're going to be given this and asked if it's a function. You're going to be given this. What are you looking for? X's. If they are the same, then it's not a function. What's that? No. Not done yet. All right, last thing I have for you today is called function notation. Yeah, you're not used to taking this. Page 30. Function notation is just an equation written as a function. Okay, go back to the basics. When you think of a function, think of a machine. Okay, you're going to put something in, you get something out. Now, if you look at the equation in the function notation format, it's the same thing, but what's the only thing that's different? There's an F in front of it, and that's only telling me that that's the function notation part of it. Just written in a different format, that's all. Okay, so you already know this. If I would say X is 4, what would you do? Put 4 in 4X, and then you solve, right? Okay, so you are all familiar with that. This is new to you, but not really new, because you've done it many, many, many times. So instead of, this is the equation way of telling you what X is. The function way of telling you what X is, it's going to be like this. That's the function way of telling you what X is. Instead of saying X is 4, they're telling you that we want you to put in the function 4 in for X. That's all. And then you're going to solve. So for example, what you would do here is you'd say, okay, 2, if this in the function they want me to put 4 in for X, and I would solve that. It's technically, right, it will equal something, which is going to be your output. Okay, so think of this as a machine. You're putting this in. It's like your money, putting it in. You're going to get something out. Okay, so I want you to start thinking of it as a function. Putting it in, what am I going to get out? Okay, does that make sense to everybody? So for example, this is what it's going to look like. They're going to give you a function. So here's your function machine. Your machine. And what are they telling you in the function way that x is going to be? X is going to be 5. So you're going to take your function, 4x minus 7, you're going to put 5 in for it, and you're going to solve, just like normal. So 20 minus 7, 13. Guess what you get out after you put 5 in? You get 13 out. So your answer would be 13. It's the exact same thing we've been doing, only it's a different format, just a different way it looks. That is it. So if I, over here, what's it telling me that x is going to be? Okay, so then I'm going to say 4 times negative 6 minus 7, which would be negative 24 minus 7. Keep change. I get negative 31. So I put in 6, got out negative 31. Negative 6, negative 31. That's all. Simple, right? Okay, let me tell you a mistake people make. They do this. They say, oh, well, I don't really remember what that is, but this looks alike, so I'm going to write it like this. And then I'm going to try to solve it. No, that's not it. They're just telling you by this, in the function, that's what they want x to equal. That is it. Then you take that 5 and you put it in for x, and then you solve. Try these two by yourself. Here's your function machine. Should be an equal sign in there. You can do both if you want. All right, so first one, let's see, 7. What are they telling me that x should be? Okay, so then it should look like this. 6 times, oops, that shouldn't be like that. 6, 7 plus 5, 42 plus 5 should be 47. So what did you put in and you got out? Okay, that's the function machine. You're putting something in and getting something out. Over here, they told me x should be negative 4. So it should look like this. So what should I have gotten out? Oh, this is negative 24 plus 5, negative 19. Okay. In your book today, they might change this letter and make it a G. It's not a big deal. It's the same thing. Okay? Don't freak out. Yep. Okay. Homework.